Alright, so now we're going to look at finding the equation given a graph. So we've seen before that the A value is your amplitude, and that means the absolute value. So if it's negative, you just take the positive value. The period is 360 divided by k, and the equation of axis is whatever the c value is. So a sine function starts at the equation of axis, whereas the cosine function starts at its maximum point, unless it's been reflected. So let's look at this. In here, you can find a sine function. You could also find a cosine function. You could find an upside down cosine function, or reflected. And you could also find a reflected sine function. So every sinusoidal function has sine and cos in it. So that's why it says determine an equation for the sinusoidal function. It doesn't say sine or cos. So sometimes it'll say sine, sometimes it'll say cos, sometimes it won't say any. And you can just decide what you want. So you have to look at it and find your function, whether you're going to do sine or cos. So I see sine here. So I'm going to find the equation of that sine function. I'm going to make this a little darker. Okay, so we're going to find the equation of that cycle. So let's find some things about it. We have our equation of axis here. So that's y equals 2. So now we know the c value. C equals 2. If we look at the amplitude, so the distance from the equation of axis to the maximum point, that's 2. So the amplitude is 2, which means the a value is 2. And it's positive 2 because I'm using a sine function that hasn't been reflected. So that's C. We got A. Now we got to talk about D and C. So D, or horizontal translation, or phase shift, all means the same thing, is 90. So I moved positive 90 degrees from 0, because normally sine would start here and look like that, but it's been moved over to 90. And again, that's just the sine function that I'm finding. It could have been something else. You know, I could find one that starts over here. Or I could use the one that starts here. It's just, this is the one that I saw first, so that's the one I'm using. So we have the D value is 90. So the last thing that I'm missing is K. So the period is from 90 to 810. So if we're going from 90 to 810, that means we went 720 degrees. The period is 720. But that's not the K value. If period is 360 over K, that means K is 360 over P. So the K value, 360 over 720, is 1 over 2. So now we need to take all of these pieces of information. And put them into the equation. So a value is 2. We found a sine function where the k value is 1/2. We had a phase shift of 90 degrees, and the equation of axis was 2. Okay, now I could have also found a cosine function that's here. I could have found a reflected one that's here. So let's say, for instance, I chose this cosine function. The amplitude would be the same. The period is the same. So the k value would be the same. The equation of axis is the same. The only thing that would change is the phase shift. So for this one, the phase shift would be 270 degrees. So instead of writing sine, I would write cos. And instead of writing 90 degrees, I would write 270. But everything else would be the same. So let's do another one here. Again, it just depends on what you see. So you could see a cosine function here. You could see a reflected cosine function there. We have a sine function here. I have a reflected sine function here. It depends on what you see and what cycle you want to do. So let's do 2. Let's take a cosine function here. In blue. And I'll choose a sine function. Just make it harder. Let's do a reflected sine function over here. Okay, now the easiest one to do would have been this sine function there, but who wants to do easy things? All right, so equation of axis. Let's take our c value here. C value, usually you can just look at it and figure it out. If the maximum point is 1, the minimum point is -7, that's 8 apart. So 4 would be where your equation of axis or amplitude is. So 4 down from the top or 4 up from the bottom, right? So you look at how far apart they are, figure out what the middle is. So it's going to be -3. So we already figured out the amplitude, which is 4. Again, it's halfway between the top and the bottom. And the d value is going to change depending on which cycle we're talking about. So let's leave that till after. Let's look at the k value. So that's 360 divided by the period. So now let's look at what the period is. So again, it doesn't matter which cycle we talk about. We could be talking about this one here. We're talking about that one there. So because we have the numbers available to us there, we can look at that one. We could also look at the easiest one to do, which is starting at 0, right there. So we can see it's 180 for all of them, right? 180 degrees. So we do 360 divided by 180, which is 2. So k value is 2. So no matter which cycle we choose, whether it's sine or cos, those values would be the same. So now let's look at the blue highlighted version here. That's going to be, call it f at x. It's not reflected. It's a cosine function that has been reflected, so I'm going to put positive 4 cos. We figured out the k values too. Now I need to figure out my horizontal translation, or my phase shift. So we've gone from 0, where cos is normally, this way, to start at this point here. So let's figure out what that point is. Every 2 boxes is 45. So we've gone 2 boxes to the left of 270. So 270 minus 45, it's going to be 315. So because we went in the negative direction, I'm going to write plus 315. And then my c value is -3 because my equation of axis is -3. So this would be our blue cycle. But what would our purple one be? So it's a sine function that's been reflected, because going down and then up. So I put -4 sine, right? The amplitude is the same. My period is the same, so my k value is the same. But my phase shift is going to be different. So I moved 90 degrees in the positive direction. So I'm going to put minus 90. And the c value is the same. So you can see that the same sinusoidal function can have more than one equation and still be equal. And so if it doesn't specify sine or cos and it doesn't specify which cycle, you can pick whichever one that you see and want to do. Okay, so what happens if we just have a description? So the sinusoidal function has an amplitude of 6. So we got our a value. Now, it may be negative. We got to figure that out. It has a period of 60. So now we can figure out k value. 360 divided by the period, which is 60. So that'll be 6. And a maximum at 0.8. So if it has a maximum at 0.8, we can choose what that means. I can choose to say that the function starts at 0.8, or my cycle anyway starts at 0.8, or I could choose to say that it's the maximum point of the cycle, but not necessarily the starting point. But I think that when it says the maximum, it's easiest then if we just get a quick sketch to say that it's, if the maximum is at 0.8, so here, it means it's going to go down from there. And if the amplitude is 6, that means the equation of axis is at 2. And you don't need to do a graph to get this, but sometimes it's easier. So that means, and if the equation of axis is at 2 and the amplitude is 6, then the lowest point would be -4. So again, without getting a real accurate drawing of this, that means it's going to do that, right? Something like that anyway. So if we take the maximum point as the starting point, then we could see that it's a cosine function. You could also consider it the maximum of the cycle, and then if you continue backwards, you'd have a sine function. But why make it hard on ourselves? We know the maximum point, so So that can be our cosine function, and it's the cosine function that hasn't been reflected because it's the maximum. So we're going to do cos. So we have our c value now because we used our amplitude to figure that out from the maximum point. A, K, and C, the only thing we're missing is D, but because the maximum point is at 0, 8, D would be 0. So we have everything we need. The amplitude is 6, and it hasn't been reflected. It's a cosine function. The K value is 6 with no change in horizontal translation, so it'll just be 6x. And our equation of axis is 2. Okay, the last one here. Sinusoidal function has amplitude of 8, a period of 180, and a minimum at 0, -3. So we don't have to draw this to get it. Amplitude of 8. So A is 8, maybe. We'll see in a second. K is 108, or 360 divided by 180. So that's 2. And there's a minimum at 0, -3. So if we think of it, the minimum being at 0, -3, that would be like the bottom of the trough, right? So the lowest point. So a reflected cosine function looks like this. So if the minimum point is 0, -3, that would be here. So it's like the beginning of a reflected cosine function. So if it's at the minimum point is at 0, -3, and this is the cycle that I'm choosing, that would mean D is 0. Again, no reflection, or sorry, no phase shift. But if the minimum was somewhere else, say 45, -3, then my phase shift would have been 45. It just depends on where your minimum point is. So we have A, K, and D. We don't have C. But if the minimum point is at -3, and the amplitude is 8, we're going to add the amplitude. Right, so we can go A up from the minimum point, 8 up from the minimum point, so that would be 5. Okay, so if you want to draw it out, you can, if that helps you. You would do something like this, where the minimum point is at 0, -3. Since the amplitude is 8, if I go up from there, 8 from there, I get to 5. So that would be my equation of axis. And we'd go higher from there, obviously another 8. So the maximum point would be at 13, but we would get something that looks like this. Okay, again, you don't need to do that to get the equation. So it's reflected. So it's going to be -8, not +8, because it's the minimum point. It's cos K is 2, no phase shift, and C is 5. But let's say they gave you this information, but they said find a sine equation. So it says sinusoidal here, but that doesn't mean find sine, it just means sine or cos. But if it said determine the sine equation of the function, or using sine, then it does help to draw it out, because then you can figure out where your sine function is starting. So let's say I did say we want to find the sine function here. I need to know where this is. Well, if the period is 180, that means this completes in 180 degrees. And remember what we do, we take the 180 and divide it into 4 sections. So that'd be 45 degrees. So every 45 degrees, something is happening. Right, so you divide it into 4 sections, so now you know that your sine function, or one of the sine functions, would be starting at 45 degrees, or have a phase shift of 45 degrees. Okay, so anytime you want to figure out where any point is on your function, just take the period and divide by 4 and figure out where each section is. Okay, if that helped. Good luck.